So how can we implement stack using single linked list? Okay, so normally, first let me represent right that linked list in the stack format. Stack format means what? Last in, first out. So parallelly, I will write the code for this one. See, we know that according to our stack knowledge, stack operations we are performing using the top. So using the top variable only, we will perform all these things. We will perform all these things using the top. Here, initially, as usual, we are taking that class stack using list. Stack using list. I'm taking like this. As usual, the node is common. Class node is a single linked list. One is for storing the data. Second one is to connect the link. But all the operations you need to do using what? Static node type top. Initial value is a null. Initially, top is not pointing to anything. So initially that value is a top value equals to null because no values in the stack. Okay. First node I want to create. Same operations. I'm doing that while true condition is true. All the stack operations we are performing. One is to push the element. One is to push the element. Two is for pop the element. Pop the element. Three is for traverse the element. Traverse the list. And four is for exit directly. We are taking. And we ask them enter the choice. Creating the object. Creating the object. Importing that code. We are writing here first. Enter your choice. Enter your choice. The first one. In choice is equals to scan dot next in top. After collecting the choice, as you know, just simply we are calling if the choice is equal to 1, push element, pop element, traverse, else if exit, end of the program, and just simply quit. Quit using the break. Else invalid choice. Else invalid choice. That is. Okay. Now we are doing the first one. If choice is equals to 1. Already see, top is not pointing to anything. Top is pointing to null. If the choice is equals to 1, to push the element, first of all, we should read the element. We should read the element that we ask. Enter element to push. Enter element to push. Scan dot next int. Scan dot next int. That we are calling push function. Passing that element. Where is the push function? Write the code. Static void push. Taking the element. How can we push? First of all, simple way of writing the code. It's very simple way. Just taking that node, creating that node. Temp is equals to new node of node will be created at some location. This is node creation. This is node creation at some location. For example, it's 1,000. It's 1,000. Whatever the element they entered, that element we are adding to this data. Temp2 data equal to element. Here it is what? Simply 10 added. 10 added. It is actually stored in temp initially. Temp, remember, just a temp2 data. Temp2 data equal to element. Node is ready. Now connectivity, very simple. Look at this top value. You have to store into this one. Try to understand the code. Top value we are storing into this one is nothing but temp2 link. Temp2 link is equal to top is a null. Now top is this is the top node now. Previously no nodes. That's why top is null. Now node is there. So it should be the top node. So the temp value you have to place inside the top. Inside the top. Into top, store the temp value. Simply giving the message is element pushed. See here, then the top value null become 1,000. So top is pointing to that. Top is pointing to that newly created node. So once this method execution completed, then this will be deleted. See, top is pointing to this top node. Pointing to this top node. Again they have called the push function. Again reading the element and called push element. Again node creation, same story. Look at this. First creating the node is a new node. At some location address, the node will be created. The node will be created at some address. That address initially we are storing into a variable, temporary variable. The element what you are going to push, that you are adding to this data location. Into the data field, the 20 will go into the data field, 20 will go. Okay. Next one, look at the two steps. This link actually 1,000 you need to connect here. Reverse linking is connecting like this. So this 1,000 you have to place here. 1,000 means what? Is a top. Top you are storing into temp2 link. Storing into temp2 link. That is top value you are storing into temp2 link. Here it is. That value will store 1,000. Just linking in reverse direction. Easy way of linking. Like this we will link. Next one, now it should be the top node. Na? The new node is always the top node. So into the top, you have to store 2000. 2000 means what is a temp value you have to store. Into the top, temp value will store. So how many times you call? For example, third one is a third node. First of all, that node address 3000 will store into the temp variable. Will store into the temp variable. That is. And the value will store into this one. Again, same steps. First top value 2000 will store into temp to link. Nothing but newly created node is reverse connection. In reverse order, it will connect like this. It will connect like this. Now it should be the top node. Na? So temp value will be stored into top. Temp value will be stored into top. Then once the function execution completed, it will be deleted. So that's why I already told you that. You try to understand this code. Try to understand this code. Okay, is a one. Now, just like this is a push. Second one, suppose if you want to delete, always what you have to delete? The top one only you have to delete. I'll explain, but you have to write the code now. Suppose already top is pointing to this one. Okay, now top is a 3000 is already pointing to this one. Now, if you want to delete this means what? Very simple. First of all, place this into one temp variable. Make the top pointing to the previous one, 2000. Top equal to top to link. So now top is pointing to this one. So you need to delete this one. Delete this one means what? Temp to link, make it null. Temp to link, make it null. So then automatically, whenever you place null here, then here this link will be disconnected. The link will be disconnected. Then once function execution completed, that will be garbage collected. If no one is pointing, that will be garbage collected automatically. Okay. So simply how can we do? Is a pop function. I'm doing this pop. Pop. Here it is. Static void pop. First checking if top equal to null. Simply to say that stack is empty. Stack is empty. Nothing is there to delete. No, if it is there, if element is there, the top element only we have to remove. Na? Suppose 30. 30 is the top element. Top is 3000. 3000 to data. That message we are providing. Just giving the message is popped. Popped. So what is that? Simply top element, top to data is deleted. Top is 3000. 3000 to data is deleted. That is. But remember, now you need to delete this. So first, store the top value into one temporary variable. Node temp is equal to top. Temp equal to top. Now make the top is pointing to 2000. Already top is 3000. Na? Make it pointing to 2000. So into top store, top to link value. Top to link value 2000 will store 2000. Got it? Right. Now top is pointing to this one. Pointing to this one. Now we need to delete this. So here you need to place null value. Top to link equal to null. Top to link equal to null. That's all. Once this function execution completed, automatically it will go out of that scope. Then temp variable will be deleted. Whenever temp variable is deleted, as you have disconnected this connection by placing the null value into the link part, then that node will be garbage collected. That object will be garbage collected automatically. Simple. Hope you got the point. It's a 1. This is pop. Sir, we keep on deleting means what? It will come to this place, null place. This one deleted, this one deleted. Finally, 1000 to link is null. That is a top. When no more elements are there, that is. So, this is pop. This is pop. Simple. Okay. So based on these two, now you need to write the code for display. Same story for displaying the details. The same for checking if the list is empty or not, stack is empty or not. If stack is not empty, then repeat the loop until that value is equal to null. Don't move top value. Take one extra variable temp. Then you keep on moving. First display this, then move. It will come to here. Display this, move. Come to here. Display this, move. Until it is null, you keep on display. The simple code you have to write. Please write, everyone. No one written. Code in copia. What is that? Only the traverse code, then you need to complete. And one more thing, same just like okay, this one I'll explain. I'll give one more task to you guys. Push pop and followed by traverse, static void traverse. Directly, if the option is 3, we are just calling that method. Same one, first we need to check if it is an empty. If the top equals to null means what? That stack is empty. System.out.println stack is empty. Else. Then stack has elements. So take one temp variable. Into the temp, store the top value first. So while temp is there, yes, first temp value starting from what? Starting from 3000. So first 3000 to data, print it. 3000 to data. System.out.println system.out.println, just printing that temp2 data. After printing temp2 data, now temp should come to here. Make it pointing to this node. Temp2 link. Temp equal to temp2 link. So first temp value starting from 3000. Temp value starting from 3000. Next the value become 2000. Next the value become 1000. Finally 1000 to link means what? Value become null value. When it is a null, it is terminated. It is terminated. That's it. Okay. So until it is null, we are displaying the details. Until it is null, we are displaying the details. That is simple one. Hope you got it. So this is simply called stack using single linked list. Using the front and rear operations, queue using single linked list also you have to complete today. I'll share that image. Okay. First complete this everyone. You can leave.